Good afternoon, my YouTube viewers. In this particular video, what we were going to do is we're going to compare sample statistics. In particular, we're going to compare the sample means against the sample variances. So in order to compare the sample statistics in Python, what we're going to need to do is we're going to need to import the two libraries that we're going to use to execute the program that we're going to make. So we're going to import NumPy as NP, which is the numerical library, and we're going to import matplotlib.pyplot.splt as the visualization library. And then what we're going to do is we're going to generate population data. And so the first thing we want to do is we want to set our seed. And the reason why we set our seed is because we want to initialize the values in the program. So every time we run the program, it will be initialized to the same values. So that's np.random.seed brackets 42, or you can put any number that you want in the brackets. I just put 42 in there. Okay, now what we're going to do is we're going to create a normal distribution. So population equals np.random.normal brackets loc is your mean of 50, comma scale is your standard deviation of 10, comma size is your sample size of 10,000. And we're going to set parameters for sampling. So your sample size is going to be 30 and your number of samples is going to be 1,000. And then so what we're going to do is we're going to collect the sample statistics. So sample means is going to be a blank or an empty list, and sample variances is going to be an empty list as well. And so what we're going to do is we're going to create a for loop. So for underscore and range num samples. So I think we said num samples is 1,000. Sample equals np.random.choice brackets population, comma sample size, comma replace equals false. So that means it's not going to replace the number whenever you take a sample, and then the choice indicates that you're sampling it. Sample means dot append np dot mean sample, and sample variances dot append np dot variance and sample. So that means for the 1,000 sample sizes, 1,000 times that you sample the distribution. So in sample means you're going to have 1,000 elements of the mean, and in sample variances you're going to have 1,000 elements of the variances. So now what we're going to do is we're going to plot the sampling distribution of the sample mean and sample variance, and we're going to do that by creating two histograms really. So fig, comma ax equals plt dot subplots brackets 2, comma 1, comma fig size equals 10, comma 8. So now for our two histograms, for the sample means, ax0 dot hist brackets sample means, comma bins equals 30, comma color equals sky blue, comma edge color equals black, comma alpha equals 0.7. And then for ax0 dot axv line brackets np dot mean of the sample means, comma color equals red, comma line style equals dashed, comma line width equals 2, comma label equals mean. And then so we're going to set the title as sample distribution of the sample mean. X label is going to be sample mean, and Y label is going to be frequency, and you're also going to get a legend. And then so we're going to create a histogram for the variances as well. So ax1 dot hist bracket sample variances, comma bins equals 30, comma color equals light green, comma edge color equals black, comma alpha equals 7. So ax1 dot axv line brackets np dot mean of the sample variances, comma color equals red, comma line style equals dashed, comma, line width equals 2, comma, label equals mean. So we set the title of sampling distribution of the sample variance. We set the X label as sample variance. We set the Y label as frequency, and you get a legend. And then it says we're going to adjust the layout and display the chart, and we're going to display the chart. So the first thing that we're going to do is this is the sampling distribution of the sample mean, and you can see that the sample mean is 50 and it is a normal distribution. So now we do the sample distribution of the sample variance, and so in that instance the mean is 98.42, but you see that the sample variance is skewed on the right. So even though the sample distribution was normal whenever you tested your mean, whenever you test your sample variance, it's a bit skewed. So that just gives you an idea of how you can compare the distributions and how you can compare the mean against the variance. So that's going to close this video, and in the next video I will be talking to you about some more statistical topics. So watch this space.